Hello, everyone. This is Skylar from CS345. I wanted to make a quick video. I saw that a lot of people were struggling with Quiz 7, and I know it's pretty confusing, especially because there's no good online resources to help us learn. So I thought I'd make a quick video because I'm like 70–80% sure that we're going to see one of these problems on the final today, and I just want to make sure that everyone is prepared since obviously this final is worth so much of our grade. And yeah, so I'm going to make a video real quick to show you guys compression, and then I'm going to make another video to show you guys decompression. So we're going to start right here with the compression side of things. We get our message right here, ABCD, ABCD, DCBA, DCBA. This is the one from the quiz, so if you guys want to check out my work, I already posted it in the Discord. You guys can follow along, but I'm just going to kind of do it from scratch here so you guys can kind of see like the way that you have to think, the patterns, and hopefully with this video you guys will be able to start recognizing it and you guys will be able to get it yourself when we inevitably have to do it tonight. So the first thing you want to do when you get this message and you're doing compression is you want to set up your code table. So the first thing you do is you want to look at the string and you want to look at each individual character and you want to write down each unique character. So right off the bat, I see that all of our unique characters are A, B, C, and D. So I'm just going to go ahead and write those in. We got A, B, C, and D. And then the value of these is determined sequentially. So A starts at 0, B is 1, C is 2, and D is 3, because we need a unique way to identify each character. All right, so now we have our initial characters we can go through. We see we have all of these unique characters. So we're good on that part. So now we can start evaluating for strings, starting from left to right. So we start with the left. We have A. We already have A in our code table. So we're going to go ahead and skip that. We're going to hold on to it. And then we're going to evaluate it with the next one. So now we have AB. We don't have AB in our table, so we definitely want to go ahead and add that. So we now have AB. And again, this goes sequentially, so we can just say that this is number 4. All right. And then, so when you make an evaluation of a string, you still hold on to the very last letter, or I should say you start at the last letter that you ended with. So for us, we had A, B, so we now start evaluating at the B. So B by itself, we already have that in our code table, so we can hold on to that and we can evaluate the next thing. So we see we have BC. We don't have BC in our code table, so let me just underline that, and now we're going to go ahead and put in BC. Awesome. And then now we're going to just keep going. We're going to start at C. C by itself, we already have that, but CD, we don't have. So we can put that in. All right. So now we're going to start at D. We got D, which we already have in our code table, and then we have A. DA, that's unique. So let's go ahead, let's insert that into the code table. And I'm sure you guys can already kind of see the process that we follow. We're looking for unique strings. So we're just going to keep, we got a lot more to add, so I'm just going to keep extending our table. All right, so now we are at A. We already have A in the code table, so we move on. AB. You guys remember, we already have AB in the code table. So what does it mean? We're just going to keep going. And then we have C. Well, we know this is going to be unique because we don't have any strings in our table that are 3 characters long. So our next string we're going to add is ABC. So head on to your code table. You can go ahead and add ABC. That's going to have the value 8. So now we're going to start at C. We have C, which we already have. We have CD, which again we already have. And then we have CDD, which that's unique. CDD, we don't have that yet. So let's go ahead and add that into our code table. And sorry if my handwriting's a little bit messy. I am using just some free software, having to draw with my mouse, but I definitely want to get this video made for you guys because I want everyone to pass this class tonight. All right, so now we can go ahead and we can evaluate from this last D that we evaluated. So let's see, do we have DC? Looks like we do not have DC in our code table, so we can take that. DC is unique. And the reason that we have to create this code table is because at the end, when we do our outputs are based solely on this code table. And I'll explain that when we get to the actual compression part. But for now, let's just finish up our code table. So we evaluated DC, so the last thing we're looking at is C. So now we're looking at CB. I don't think we have CB in our table yet, so let's go ahead and add that. All right, and now we're looking at BA. BA we do not have in the table, so let's go ahead and take BA. It's going to be the value 12. We still have a little bit more to evaluate, so I'm just going to keep extending my table. All right, so now we've got AD. I don't think we have AD in the table yet, so let's take that value. All right. So we did AD, and now we are at this value D right here. So we evaluate DC. We know we already have that in the table, so we can't take that string. It's not unique. So we have to keep going, and we'll get DCB. So let's go ahead and add DCB. Which will be at 14. And so now we're at the very last step. We have the value B, which we already have, and then we have BA, which we also already have. But what's tricky about this algorithm is you always have to be able to kind of quantify the last couple of characters in your message. So even though we're starting at B, and we already have B, and we already have A, we already have BA, we're actually going to back up. We're going to have to create an entirely new string because we want to have this last little bit on there just in case, because we have to be able to evaluate the whole thing. So you're just going to keep backing up until you find something unique. Luckily for us, that's pretty easy. We have BA, which is obviously not unique, which is why we have to go backwards. But then we have CBA right here. We don't have CBA in the table yet, so we can go ahead and add that, and that will represent our last few characters. CBA 15. And that's what your completed code table should look like for this problem. 15 unique, like a 16 technically, 16 unique strings, characters, whatever you want to refer to them as. So now we can go ahead and we can actually get into compression. We can get into the table. So this part is when things get a little bit tricky. Not in terms of input or buffer, but trying to determine what your output is can be difficult. So I'm going to try and explain it. I'm going to go through the whole thing so you guys will see lots of examples. But pretty much how input works is we're just going to go down the line. We're going to go down the string like we just did, starting from the left. So our initial input is going to be A. And then our buffer is going to be whatever is left over from our previous, I guess I would say our previous calculation or our previous evaluation. But since this is the first one, we don't have anything to move over, so our buffer is just going to be A. And You can't get a unique output if you only have one character. You have to have more than one character to be able to evaluate an output. And I'll show you guys why. It's a little bit tricky to see. So then we're going to go ahead, we're going to move down our line to our next input. So we got B. So let's put B in the table, or into our input, I should say. And then, like I said before, our buffer is equal to our previous plus what we have now. So in our buffer is going to be AB. And now we're going to have our very first output. So the way the output works is we're pretty much going to evaluate the buffer except for the last character. What the last character determines is if it's unique or not. And you'll kind of see what I mean as we go on. But pretty much if we take AB as it is right now, we cannot take AB again later in this. So if we see AB again later, we're going to have to hold on to it. But for this, our output is going to be 0. And you might be asking, why is it 0? Well, we look at our code table and the output for A is 0. Remember, when we're evaluating our buffer, we're only looking at everything except the last item on the right. So this AB is considered a unique iteration of A. So A is actually what is being output here. And it's unique because of the letter B. So that's why our output is 0, is because technically our input is A. It's the unique string AB. So if we had AB again, we could not take that as an output because it's not unique. But if we had like AC later, we could also get the output for, 0 because it's a unique variation of A. I know that's a little bit confusing, but it'll make more sense as we go on. You guys will start to see the pattern. So I'm just going to keep on going. Our next input's going to be C. And so since we got our buffer A, we got that as the output, our A is gone now technically. So the only thing we're going to continue to hold on to is the B. We're going to drop our B, that's still in the buffer. So, and our buffer is B, and our input is C. So we're going to add the letter C. And now we have in our buffer the values BC. Well, we're not looking at the last character, remember, but because that's what makes it, a unique input. But this is the first time we're seeing B. This is a unique string BC of the value B. So that means we can take the value for B and put it into our output. So if we refer back to our code table, the value for B is 1. So let's just go ahead and say that our output is 1. All right, and then we're just going to keep on moving down. Our B is no longer in our buffer. We only have C, so we can actually just go ahead and move that down first if you guys like. And then we're gonna, what's our next input? We're at the 4th input, so our input's gonna be this guy right here, letter D. So we input D, we add it to the buffer. And now we have C followed by D. This is a unique string. We haven't seen C, D yet. So this is a unique instance of C. So if we refer back to our code table, C is the value 2. So we can go ahead and add the value 2. I'm just going to go ahead and extend my table real quick. All right, so now we can go and we can evaluate the next section. So we have now the letter A. Actually, I should say we drop our buffer D because we still have the letter D. But yeah, then we go ahead and we add the next character, which is A. And then we can go ahead and we can add our input to our buffer. So now we have the value DA. And this is a unique instance of D. We don't have DA in our buffer yet, or we haven't had it yet, I should say. So this is a unique instance of D. So we're going to go ahead and find the value for D, which is 3. We're going to go ahead and add that to the table. And we're just going to go ahead and continue on. A is what's left over in our buffer, and then we're going to evaluate what's next. B. So B is our next. Oh. B is our next input. What the heck? Relax. Keep resting my hand on the mouse pad. Or maybe my computer is just not having a good time. There we go. B. So now we have a B in our buffer. And now this is what I was talking about. So earlier we had a B, right? Which gave us the output 0 because it was a unique variation of A. We hadn't seen AB before, so it was a unique output for A. Well, here we have AB again. This is actually not going to give us an output. We've already seen this before. We already know that AB is in our string somewhere. Because, this is not a unique variation of A. This is just, AB. We've seen this, so there is no output. We just continue on. And then same thing, we drop our buffer. We didn't evaluate anything, so we actually still have both of these guys. We have AB. And then our next input, I don't even have to look back up. I know it's C, so our next input is C. So we go ahead and add that on. So now I have 3 characters. So again, the C is what's determining, if this is unique or not. And what I'm evaluating is this right here, our AB. So we haven't seen AB before. And ABC, that's a unique string equal to our first character's AB. So we can go ahead and we can grab our value AB from the table, from our code table. That's the number 4, so our output is going to be 4. All right, and then we can go ahead, we can drop everything from our buffer that we did not use, which would just be C for this example. I'm going to go ahead and make my table a little bit longer because we're not even halfway done yet with the evaluations. But yeah, so we got C. Next up for our input is D. So that would give us CD. And if you look back at our code table, we've already seen CD. This is not unique. This is not a unique variation of C because we've already seen CD. If this was like CA or CB, then we could evaluate C, get another 2 in here. But it's not. We've already seen CD, so we have to hold on to this. No output for us here. And then we move on. So next is D. Next input, we drop our buffer because we didn't use anything. So now our buffer is CDD. We haven't seen CDD yet. This is a unique instance of the characters CD. So we can go ahead, we can look at our code table and see what the value for CD is. It's 6. So we can go ahead and drop 6 in our table. And then since CD is equal to 6, this is no longer in our buffer. It's been evaluated, so we just drop our D. And then we continue on. So next input is C. DC is now in our buffer. And we have to look back at the table. Have we seen DC before? Doesn't look like it. We've seen DA before. That was a unique instance of D. Now we have DC. That's another unique instance of D. So we can take that as our output. We can say that our output is 3. Because obviously in the code table, D is equal to 3. And this is another unique instance of D. We haven't seen DC before. We've seen DA before, but that was unique. And DC is also unique. So we can go ahead and take the output. And we can continue. We can drop our buffer, which is C. And then our next input is B. So now we have CB in our buffer. Have we seen CB before? No, we've seen CD before, but we haven't seen CB before. So this is another unique instance of the letter C. So our output is going to be equal to our value C in our code table, which is 2. All right, I'm gonna go ahead, continue to make the table longer because we still have a little bit more to go. All right, and then we can go ahead, we can drop what we didn't use in our buffer, which would be the letter B. And then we have our next input, the letter A. So now our buffer is BA. So now I gotta look back at my table. Have we had BA before? No, we've had BC before. That was a unique instance of B. Now we have BA, another unique instance of B. So we can take the output of B, which in our code table is the value 1. So we'll put 1 in the output, and we'll just carry on. We'll drop our buffer of A. I hope now, by this point, you guys are starting to see the pattern, kind of how we go through this algorithmically, and we do the same thing every time. We're just evaluating everything but the right letter. The letter that's just added as our input is just letting us know whether this character or string is unique or not. And yeah, we're just going to continue on. So we got that letter A, which in our initial string is this letter right here. So we move on to the next input, D. So we have the letter D. We add that to our buffer. So now we have AD. Is AD a unique instance of A? I would say so. We've only seen AB so far. So AD, that's another unique instance of A. So we can go ahead and add 0 as our output, because that's what's in our code table, A equals 0. Cool, so now we can go ahead, we can drop our buffer, or at least what's left over after our output. Across, so it's obviously a 0. It's not a very circular 0, but that's okay. And then our next input is the letter C. So now we have DC. Have we seen DC before? Oh yeah, we have DC right up here. We've already evaluated this, so it's not unique. We can't put this in our code. Remember, we're only looking for unique instances of these characters or strings. So that means that there's no output for this part. We can just go ahead and cross on over and then drop our buffer. And since we didn't evaluate anything, we still have the entire buffer, which is DC. And then we have our next input, the letter B. We're getting pretty close to the end already, which is awesome. So now in our buffer, we have DCB. So have we seen DC with the letter B before? Is this a unique iteration? I would say so. We haven't seen DC with the letter B yet, so we can evaluate our value DC right here because it's unique. We've never had DC with the letter B. And if we look back to our code table, let's see, where is DC? Right here. So DC is equal to the value 10. So we can say that our output is 10. And then we continue on. We drop our buffer that we didn't use, which is B. And then we're on to our last input finally, letter A. So now our final buffer is BA. And the way that the very last evaluation works is you can just take the letters as is. You don't have to care if it's unique. It's the very end of the string. So we're just going to take this whole thing as it is. BA, we don't care, if this is a unique instance of B. We are evaluating BA in its entirety. Because obviously if we didn't, then we would never evaluate A. It would never get compressed, and we would always lose the last letter of our string if we compressed. So we evaluate BA, which is right here in our code table. That's value 12. So we just move on over to 12. And that's it. That's our completed compression sequence. We have our full code table. So the last thing to do is just write out what our string is. And the way you evaluate the string is it's simply your output, just from top to bottom. So we could say that our final string, our answer, is equal to 0. Actually, you know what? I'm just gonna write this as text so it actually looks decent. So our final output is going to be the string 0, 1, 2, 3, 4, 6, 3, 2, 1, 0 again. And then we have, I believe, 10 and 12. 10 and 12. So this would be your final answer for compression, your string that you've created out of your outputs from, doing the compression table. So yeah, and then this string is exactly what we're going to start with when we do our decompression. And you guys should notice a little bit of a pattern here. You see 0, 1, 2, 3, 4, 6, and then 3, 2, 1, 0, which should make a lot of sense because if you look at our string, it's ABCD, ABCD, and then it's, in the middle, it goes backwards, DCBA, DCBA. So that's why, in our output string, you see 0, 1, 2, 3, and then you eventually see 3, 2, 1, 0, because we're evaluating it forwards and then in reverse. So your output should, kind of match numerically, it should match your input string. This one was just easy to tell because obviously we have these two inputs that are then immediately reversed. So it's easy to see that pattern come out in your string, but it's just like a quick way you can double check to make sure that your work is all right. All right, well, that's all I have for this video. Here's all of the work in its entirety. If you guys want to take a picture or whatever, or if you guys just want a still frame on this for when you guys take the exam. But yeah, I will shortly make a video about compression and then I will get that uploaded.